Okay, now let's look at how we can use gas volumes when calculating our stoichiometry. So the question says what volume of hydrogen gas would be produced at STP by reacting 50 grams of aluminium with hydrochloric acid. So, first of all, we're going to need an equation. So aluminium solid plus hydrochloric aqueous will give us aluminium chloride aqueous plus hydrogen gas. We're going to obviously have to balance it. So I've got one aluminium here, one aluminium here. I've got 3 and I've got a 2 here. So I'm going to need to have 6 hydrochloric to put 2 there, 2 there, and a 3 here. Our known is aluminium and our unknown is hydrogen gas. So let's get started. What do we know? We actually know that we've got 50 grams of aluminium, so that's our starting point. We're going to find the number of moles of aluminium is equal to a mass over a formula mass. The mass is 50 grams, formula mass is 26.99, and it comes out to the number of moles being 1.853 moles. Now that we've got our moles known, we have to find our moles unknown using our balanced chemical equation. So the number of moles of hydrogen gas will be equal to unknown over known times the moles of the known, which is aluminium. So it would be unknown is 3, the known is 2, times the moles of the aluminium, which is 1.853, and that equals 2.7788 moles. Now we're at our final stage. We're going to find the volume of hydrogen gas at STP. So we're going to use number of moles of hydrogen gas is equal to a volume over 22.71. So the number of moles was 2.7788 equals volume over 22.71. So the volume must equal 2.7788 times 22.71, which is equal to 63.1 litres. Now check the significant figures. We've got 1, 2, 3 significant figures here, 1, 2, 3 significant figures here. Now let's look at part B. It says what volume of hydrogen gas would it occupy at 25 degrees Celsius and 105 kilopascals. Now we've already got the moles of hydrogen gas. That is not going to change. Just the volume, because we've changed the temperature and the pressure. So the first thing we're going to need to do is work out the temperature, which is 25 add 273.15, which is 298.15 Kelvin. Using PV equals nRT. The pressure is 105. We don't know the volume. The moles is the same as previously. The gas constant we get off the data sheet, and the temperature is 298.15. So this becomes 105 times volume is equal to 6,888. So the volume must equal 6,888 divided by 105, which equals 65.6 litres at 3 significant figures.